Fifth-generation cellular networks promise peak speeds up to 100 times faster than 4G. But the engineering hidden behind 5G is genuinely staggering. Let us peel back every single layer. Peak throughput on a 5G channel can actually reach 20 gigabits per second. That is roughly 10 times faster than 4G LTE, rivaling fiber connections at your home. Wireless networks live entirely on the radio spectrum. Lower frequencies travel far but carry less data. Higher frequencies pack more bits but die quickly inside ordinary concrete walls. 5G finally unlocks millimeter wave bands above 24 GHz. These ultra-high frequencies were once considered useless for mobile phones, but advanced antennas finally tamed them. Sub-6 GHz bands carry the bulk of real 5G traffic. They balance range and speed gracefully, reaching across whole cities while still pushing hundreds of megabits per second. Massive multiple input multiple output stack 64 or more antennas inside a single panel. Each antenna sends and receives independent streams in order to multiply capacity dramatically. Beamforming steers radio energy toward your phone like a tightly focused flashlight. Instead of broadcasting in every direction, the cell focuses its signal exactly where each user stands. Towers alone simply cannot deliver real 5G. Engineers deploy small cells, suitcase-sized boxes mounted on lampposts, every few hundred meters across dense urban neighborhoods. Network slicing lets one physical network host many distinct virtual networks. A factory robot slice gets ultra-reliable links while a streaming slice gets raw throughput. Edge computing pushes servers right next to the radio antenna. Instead of a round trip across the country, your request hits a node mere milliseconds away. 5G targets 1 millisecond of air interface latency. That is roughly 30 times tighter than 4G, fast enough for remote surgery robots and self-driving cars. 3 pillars define every 5G use case. Enhanced mobile broadband, ultra-reliable low-latency communication, and massive machine-type communication for billions of connected devices everywhere. 5G can support 1 million connected devices per square kilometer. Tiny sensors, meters, and trackers all sip very low power and report data through narrow-band channels. Self-driving cars need to talk constantly to each other and to the road. 5G provides the bandwidth and predictability that vehicle-to-everything communication truly demands. Augmented and virtual reality headsets stream rendered frames live from cloud GPUs. Only 5G low latency makes the wireless tether feel like no tether at all. New Radio is the official name of the 5G air interface. Replacing the older LTE radio, it scales from a fraction of a megahertz up to 400. Orthogonal frequency division multiplexing splits each channel into thousands of tiny subcarriers. Each one carries a slice of your data, parallel and resilient against severe multipath fading. 5G introduces flexible numerology. Subcarrier spacing scales from 15 kHz all the way up to 240, letting engineers tune for latency or efficiency per slice. The radio access network has now split into 3 distinct pieces. The radio unit, the distributed unit, and the centralized unit, each handling a different protocol layer. The 5G core abandons monolithic boxes entirely. It runs as cloud-native containers, deployed across data centers and orchestrated like any modern microservice fleet would be. Service-based architecture exposes every core function as a stateless API, authentication, mobility, session management, all callable over standardized HTTP/2 interfaces. Control and user plane separation lets data forwarding scale completely independently from signaling. Heavy traffic stays at the edge while control logic runs centrally elsewhere. A single 5G antenna panel can hide 384 tiny radiating elements inside one tile. Each element is smaller than the average human fingernail. Phased arrays adjust the timing of each element by mere picoseconds. Constructive interference forms a beam that swings across a sector thousands of times per second. Every cell site needs backhaul, the pipe back to the core. Fiber dominates, but microwave links and even satellites step in where digging trenches proves impossible. Hauling 5G traffic demands 10 gigabit per second fiber to nearly every site. Operators are laying millions of kilometers of new glass to keep up with the load. Network densification means cells per square kilometer instead of cells per city. Some dense downtowns now host one cell every single block, an order of magnitude denser. Governments auction spectrum bands to carriers. The C-band auction in the United States raised over $80 billion in 2021 for spectrum rights alone. Frequency reuse lets neighboring cells share the same band by carefully managing interference. Beamforming makes reuse factor 1 finally possible across an entire network. Power efficiency matters everywhere. A typical 5G base station can consume 3 times more electricity than the equivalent 4G site, so engineers chase every single watt saved. Sleep modes shut down radio chains the moment traffic drops. Symbol-level micro-sleep saves around 30% of energy without users ever noticing the gap. 5G modems are silicon marvels. The Snapdragon X75 chip integrates billions of transistors on a 3-nanometer process, juggling data, voice, and timing simultaneously. Inside every modern 5G phone sits a modem dedicated entirely to radio. It handles waveform shaping, error correction, and protocol stacks at multi-gigahertz clock speeds. Qualcomm, Samsung, MediaTek, and Apple all race to ship the most efficient 5G modems. A single watt difference can extend phone battery life by hours per charge. Non-standalone 5G piggybacks on existing 4G core networks. Standalone 5G runs on its own pure cloud-native core, unlocking slicing and ultra-low latency features. When you drive between cells, handover quietly keeps your call alive. 5G uses conditional handover, prepared completely in advance to cut interruption down to milliseconds. Carrier aggregation glues several frequency bands together into one virtual pipe. Your phone might simultaneously use 4 chunks across sub-6 and millimeter wave for maximum download speed. 5G security tightens nearly every weakness from earlier cellular generations. Permanent identifiers are now encrypted before transmission, blocking the IMS eye catchers police once relied on. 5G authentication relies on a fresh AKA protocol. Mutual proofs between your device and the core prevent rogue base stations from harvesting credentials silently. All user traffic now travels encrypted with 256-bit ciphers. Even the radio control signaling is fully protected against tampering on the air. Industries lease custom slices for unique needs. A hospital might book an ultra-reliable slice for its ambulances. A stadium might buy a massive throughput slice for live broadcasts. Private 5G networks belong to a single enterprise. Factories, ports, and mines deploy their very own gear to keep latency, security, and coverage entirely under their control. On the factory floor, robots use 5G to coordinate within microseconds of each other. Replacing miles of Ethernet cabling, the wireless link survives forklifts, sparks, and oil splatter. Surgeons have remotely operated robotic instruments across continents using 5G already. Ultra-low latency turns kilometers of distance into something a steady human hand can compensate for. Connected drones use 5G for both command and telemetry. Beyond visual line of sight, flights need uplink for high-definition video and downlink for navigation correction. OpenRAN breaks the long history of vendor lock-in. Standardized interfaces let one operator mix radios from one company with software from another. Ericsson, Nokia, Huawei, Samsung, and ZTE supply most of the world's actual 5G gear. Geopolitics now shapes who builds whose national networks. Already the standards bodies sketch what comes next, called 6G. Terahertz spectrum, integrated sensing, and AI-native radios target deployment by 2030 for the next leap. Real challenges still remain. Coverage gaps, growing electricity bills, and confusing marketing all linger. Real 5G is engineering, not a logo glowing on your phone status bar. From beam-formed antennas to cloud-native cores, 5G is the most ambitious wireless overhaul ever attempted. The radios you cannot see hold up the entire world you can.